London Electrobus Company started running the first ever service of battery electric buses between London's Victoria Station and Liverpool Street on July 15, 1907. The first battery buses were mostly small, mini or midi buses. The improvement of battery technology from around 2010 led to the emergence of the battery bus, including heavier units such as 12.2-meter standard buses and articulated buses. China was the first country to introduce modern battery electric buses in large scale. In 2009, Shanghai catenary bus lines began switching to battery buses. In September 2010, Chinese automobile company BYD began manufacturing the BYD K9, one of the most popular electric buses. The first city to heavily invest in electric buses was Shenzhen, China. The city began rolling out electric buses made by BYD in 2011, with the objective of having a fully electric fleet. Electric buses per week. Charging electric bus batteries is not as simple as refueling a diesel engine. Special attention, monitoring, and scheduling are required to make optimal use of the charging process, while also ensuring proper battery maintenance and safekeeping. Some operators manage these challenges by purchasing extra buses. This way the charging can take place only at night. It is a safe solution, but also very costly and not scalable. Another solution is ensuring that the vehicle daily schedule takes into account also the need to charge, keeping the overall schedule as close to optimal as possible. Today, there are various software companies that help bus operators manage their electric bus charging schedule. The lowered charging plate on an Arriva-Shires and Essex Wright Street Light EV bus whilst using induction to recharge its batteries at the Wolverton Agora bus stop. For communication between charger and electric bus, the same ISO 15118 protocol is used as for passenger car charging. The only differences are in the charging power, voltage and coupler. Pantographs and underbody collectors can be integrated in bus stops to quicken electric bus recharge, making it possible to use a smaller battery on the bus, which reduces the initial investment and subsequent costs. Battery electric buses offer zero emission, quiet operation and better acceleration compared to traditional buses. They also eliminate infrastructure needed for a constant grid connection, and allow routes to be modified without infrastructure changes, in contrast with a trolleybus. They typically recover braking energy to increase efficiency by a regenerative brake. With energy consumption of about 1.2 kilowatts h/km, the cost of ownership is lower than diesel buses. As of 2016, battery buses have less range, higher weight, higher procurement costs. The reduced infrastructure for overhead lines is partially offset by the costs of the infrastructure to recharge the batteries. Battery buses are used almost exclusively in urban areas rather than for long-haul transportation. Urban transit features relatively short intervals between charging opportunities. Sufficient recharging can take place within 4 to 5 minutes, usually by induction or catenary. NREL publishes zero-emission bus evaluation results from various commercial operators. NREL published following total operating cost per mile, with county connection, for June 2017 through May 2018, for an 8-vehicle diesel bus fleet, the total operating cost per mile was $0.84, for a 4-vehicle electric bus fleet, $1.11, with Long Beach Transit, for 2018, for a 10-vehicle electric bus fleet, $0.85, and with Foothill Transit, for 2018, for a 12-vehicle electric bus fleet, $0.84. A new Flyer Excelsior XE60 charge articulated electric bus in New York City.